A shining beacon of peace, progress and prosperity in the Arabian Gulf, Qatar is one of the fastest growing countries in the world. Since the discovery of oil in 1949, Qatar has capitalized upon its abundant hydrocarbon resources to build a nation that proudly celebrates the past while leading the way into the future. Driven onward by the inspiration of its leaders, the nation continues to reinvent itself to meet the needs and aspirations of its people in the 21st century. Under the wise leadership of His Highness the Emir Sheikh Tamim bin Hamad Al Thani, Qatar is going from strength to emerge as a social, economic and political force to be reckoned with on the international stage. Guided steadfastly by the National Vision 2030, all of Qatar is working together to strengthen the four pillars of the manifesto. By addressing the social, economic, environmental and human development needs of the nation, Qatar Petroleum is proud to play a central role in helping realize that vision of transforming Qatar into a sustainable, knowledge-based economy of the future. Dukhan field has been on production since 1947. Development of the Dukhan field has taken place in various stages. A concession was granted to the Anglo-Persian Oil Company covering the whole of Qatar in 1935. The exploration surveys confirmed the presence of hydrocarbons along the west coast of the peninsula. The first well in the field was drilled in 1939-40, confirming the presence of commercial quality oil. Further work in this area was suspended due to World War II. Exploratory drilling was resumed in 1946 after the war. Development of the Qatir field started from 1947 onwards, and the first batch of oil was exported from Masaid on the 31st of December 1949. Development of the other two sectors, Fahahil and Jalaiha Diab in the Dukhan field, was carried out in stages starting with Fahahil in 1954, followed by Jalila Diab in 1955. Kuf non-associated gas reservoir was discovered in 1959. The state took full control of all oil and associated gas operations in the Dukhan field in 1974 with the formation of the Qatar Petroleum Company. Its activities, including subsidiaries and joint ventures, cover exploration, drilling and production, transport, storage, marketing and the sale of crude oil, natural gas liquids, liquefied natural gas, gas to liquids, refined products, petrochemicals and fertilizers. Working together with the world's major oil and gas companies, Qatar Petroleum is reinforcing Qatar's position as the world's largest LNG producer, as well as the GTL capital of the world. Qatar Petroleum's operations and activities are conducted at numerous onshore locations in Dukhan, Doha, Masaid and Ras Laffan, as well as offshore areas, production stations and drilling platforms in the Arabian Gulf. This is Dukhan, Qatar Petroleum's first and key onshore site for the production of crude oil, associated gas, condensate and non-associated gas. Located 80 kilometers from the capital of Doha, the Dukhan field lies on the western coast of the Qatari peninsula. The field, which has been meticulously developed since the 1940s, measures about 80 kilometers by 8, with a maximum capacity of 335,000 barrels a day. It has more than 350 oil, gas and water injection wells, which are connected by a network of more than 4,200 kilometers of piping. The Dukhan field is split into three sectors: Qatir in the north, Jalaiha Diab in the south, and this one, Fahahil, in between the other two. Before the liquid stream can be pumped to Masaid for further processing, the oil and gas must be separated, purified and stabilized to meet saleable pipeline and marine tanker specifications. This is the job of the 4 degassing stations that serve the Dukhan field. Built exclusively to service the Fahahil sector, the degassing station stands in the center of the Dukhan field. It's supported by 2 remote stations, Fahahil North and Fahahil South. Together, their job is to separate the extracted well fluids into oil, gas and water streams. An oil pumping station sits to the south, while the dehydration unit is just north of the station. The Fahahil main degassing station receives well fluids from the Arab C and Arab D reservoirs, along with partially degassed crude from its two nearby support stations. Two parallel trains each provide first and second stage separation, then merge into a single train for the final two stages. The crude oil is first received in two manifolds, each containing two 10-inch production headers and two smaller test headers. The production manifolds are connected to a 16-inch header in the shut-down valve station, which feeds two 24-inch lines to the two first-stage separators. Demulsifier is injected into each crude oil inlet line to the first stage to aid oil-water separation. Valve isolation arrangements in the valve manifold ensure uniform distribution from the east and west manifolds. The well fluid now undergoes separation in a four-stage process, emerging into three distinct phases: produced water, degassed crude oil and rich associated gas. Upon completion of the separation process, each of the three distinct phases are handled independently. The rich associated gas is compressed and then dried in the molecular sieve dehydration unit. Gas is forwarded partially to the Fahahil stripping plant for further processing, and the remaining from the first stage separators to the gas lift system. The dried gas then goes to a field-wide lift gas gathering header and onto the centralised lift gas compression facility at Fahahil North. Degassed crude oil passes through an oil stabilisation system and then under level control to the site storage facility. From here, it is piped 100 kilometres east to Masaid for transportation and export via a booster pumping station at Umbab. The produced water passes through a hydrocyclone, where entrained oil is removed. The de-oiled water passes under level control to the degasser, where further traces of oil and gas are eliminated. Once the water stream has less than 40 parts per million of oil, it is no longer deemed hazardous to the environment. Water leaves the degasser under level control and is then pumped to a nearby water injection facility for use as powered water injection, which is part of a secondary recovery system for reservoir pressure maintenance. Sweet fuel gas is used as the primary fuel gas supply for the gas compressor and of the hot oil and glycol heaters. Cuff and stripped associated gas are used as the secondary fuel gas supply sources. The Fahahil main drains system consists of a main 4-inch header which services the drains from the separation systems, degassing systems, heat exchangers and manifolds. The system has three sections to drain hydrocarbons, hot oil and glycol respectively. The drain header is routed to one of the two drain sumps. The east sump is equipped with two drain pumps which recycle the contents of the sump to the desalting tanks, while the west sump unloads its contents directly to a road tanker via a single pump. Three instrument air systems work in concert at the Fahahil main degassing station. The first two systems supply the main plant, while the third is exclusive to the gas lift modifications. The Fahahil main station is serviced by three flare systems, all of which are located outside of the perimeter fence and continuously purged with fuel gas from the government gas line. Pressure relief from the plant's safety release valves, blowdown valves and pressure control valves, as well as instrument, equipment and pipework vents, is gathered into a 30-inch flare header, which passes to the flare area outside the station perimeter. The main flare line enters the flare knockout drum. Here the liquids are allowed to settle out while gases pass to the flare stack. Any liquids accumulating in the knockout drum are pumped into the desalting tanks as required. Vapour from the storage and desalting tanks, as well as pressure relief from tank vapour blower, are gathered into a 30-inch flare header that passes to the flare area. The burn pit receives fluids from the 10-inch manifold relief header, which is forwarded to the flare area. The degassing station is powered by 33 kilovolt overhead lines to three separate substations. At each substation, the 33 kilovolt supply feeds into two transformers to step down the voltage to 3.3 kilovolts. The first substation supplies power to the gas compression and gas lift facilities. a 2.2 megawatt standby diesel generator starts up automatically on failure of this power supply. The second substation supplies the tank vapor blower, while the substation supplies the main oil line pump. A fourth supply comes from the Fahahil stripping plant at 3.3 kilovolts and supplies the air compressors at the pump station. An uninterrupted power supply system with a 110-volt backup battery is in place for the station's control system. The Fahahil main degassing station is designed and engineered to meet or exceed the highest international safety standards prescribed for a plant of its type. It features state-of-the-art safety systems and fail-safe measures to provide the highest level of protection to the personnel working in the plant as well as the environment. The produced water that is pumped to the nearby powered water injection station for reservoir pressure maintenance and all flare gases are carefully monitored to ensure the smallest possible footprint, so that Qatar's economic progress does not come at too large an environmental cost. This station is a key infrastructure link in Qatar's hydrocarbons chain. The oil and gas separated at the facility goes on to be processed and used to fuel local progress as well as exported around the world. Some of it is also processed further into polymers, chemicals and fertilizers to derive additional value from the national hydrocarbon resources, which help turn Qatar into one of the world's largest exporters of high-quality petrochemical derivatives. Qatar Petroleum is proud to own and maintain the state-of-the-art facility in the Duqan field. With expert care and maintenance, the Fahahil main degassing station will continue to serve the interests of Qatar and its people many decades into the future.